Okay, so as we said, today we're going to continue with our review of basic math, and we're going to talk about one of the more powerful tools in math, which is a percent. To understand how percents work, of course, it helps to understand what the word percent really means. It's actually two words, per and cent. Per, if you think of miles per hour or miles per gallon, dollars per hour, it means for each or out of. Cent, if you think of years in a century or cents in a dollar, it's 100. So out of 100. So if you're given 38%, that literally means the ratio or the fraction 38 out of 100. Oops, it's not showing here. Let me try. So anyway, it's that easy to change a percent into a fraction because it's just out of 100. Now 38% is 38 out of 100. We would probably want to simplify that by dividing by 2 to get 19 out of 50. So let's look at some examples. Let's say we have 72%. Of course, that's going to become 72 out of 100. Both of those can be divided by 4 to give us 18 out of 25. Let's make it a little bit more difficult. Let's go 335%. Well, likewise, that's just going to be 335 out of 100. But when we look at this one, we realize that's an improper fraction. We can take out a whole number. Anytime our percent is larger than 100, of course 100% is a whole thing or one object. Anytime the percent is bigger than 100, it's going to be bigger than 1. So if we look at this, usually it's easiest to turn it into a mixed number when it's still over 100. 100 goes into 335 3 times with 35 left over, so 35 hundredths. And of course we'll still reduce the 35 over 100 by dividing both of those by 5. 35 divided by 5 is 7. 100 divided by 5 is 20. Are we all done? What do we have to remember? Have to remember that 3. I'll catch a few of you forgetting that whole number. It's 3 and 7/20. Well, how about 37.5%? Well, that's going to become 37.5 over 100. But we don't like having decimals within our fractions. So to get rid of that decimal, we're just going to multiply by, in this case, 10, because we only have one decimal place. Of course, if it was 2 decimal places, we'd multiply by 100 and so on. So 37.5 times 10 is 375. 100 times 10 is 1,000. And now both of those can be reduced. What can I divide both of those numbers by? You might see 25. 375 divided by 25 would be 15. 1,000 divided by 25 would be 40, but we can still divide by 5. Will give us 3/8. The next one, 18 1/3%. Of course, that becomes 18 1/3 out of 100. Now again, we don't like fractions within our fractions any more than we like decimals within our fractions. So to get rid of that fraction, one way to do it would be to multiply by the denominator, which is 3. 18 1/3 times 3 is 55. I'll let you verify that with your knowledge of fractions. 100 times 3 is 300. And now, of course, we're just reducing the fractions. Dividing by 5 gives us 11/60. So 18 1/3% is 11 out of 60. More common than having to convert a percent into a fraction is having to convert a percent into a decimal. The decimal version of a percent is often called a rate. So when you convert a percent into a rate or a decimal, we go back to that 38%, which was just 38 out of 100. Well, to turn that into a decimal, we're just dividing out the fraction. 38 divided by 100. When we divide by 100, all it does is moves the decimal point over 2 spots. So that becomes 0.38. Now in the medical field, it is very common, and mathematically speaking, it's not required that you put a 0 up front of your decimal point. In the medical field, however, it is accepted. In fact, here now in our nursing program, if you didn't put a 0 in front of the decimal point, they would mark it wrong. Just because of on their charts and stuff, it's sometimes that decimal point's hard to see. So looking at 0.38, that'll sometimes get read as 38 and they won't see the decimal point. But with the 0 up front, it's pretty unmistakable that there's something there. So let's convert some percents into decimals. If we had like 72%, moving that decimal over 2 spots becomes, anybody? 0.72, good. How about 90%? 0.90 or just 0.9? 230%? 2.3, good. 6%? 0.06? 7.3%. Perfect. 0.073. And here's the one I always catch people on. 1/4%. There we go, 0.0025. A lot of people want to say just 0.25, but you can convert that to 0.25, but it's still a percent. Now you still have to divide by 100 and move the decimal over 2 spots. One thing I like to talk about a lot when I deal with percents is benchmarks. And in benchmarks, 1% is one of our standard benchmarks. 1% is 0.01. 1/4 of a percent is obviously smaller than 1%, so its decimal better be smaller than 0.01. Well, let's go the other direction. Let's turn a decimal back into a percent. A decimal like 0.37. If you think of it as a ratio, it is out of 1. 0.37 out of 1. Well, we just said a percent is always out of 100. So we need to turn that back into percent by making it out of 100. If you want to look at it as a fraction, of course, this would be multiplying by 100 to turn 1 into 100. Multiplying by 100 to turn 0.37 into 37. And 37 out of 100 is 37%. Some of you may also know cross multiply and divide, where you're doing the 0.37 times 100 is 37, divided by 1 is also going to give us the 37%. For a problem like this, it's probably about the same difficulty to do it either way. In fact, we're not going to multiply this out really at all because we see that you're always multiplying by 100, which is just going to move that decimal point over 2 spots. So 0.61, you're going to move the decimal point 2 spots to become what percent? 61%. Good. 0.2 will become 20%. 3.1 will become 310%. And 0.094 will become 9.4%. Let's look at turning our fractions back into percents. We'll start out with one that everybody knows. Of course, everybody knows that 3/4 is going to be what is a percent? There we go, 75%. If you didn't know that, there's actually several ways you could go about changing that fraction into a percent. One would be to divide out the fraction to make it a decimal of 0.75 and then multiply by 100, remove the decimal point. The other way is just like we looked at with the decimals, 3/4 is 3 out of 4. We want to know, to be a percent, how many is that out of 100? You could multiply by 25 to change the denominator, or I'm going to go with cross multiply and divide. 3 times 100 is 300. Divided by 4 is 75. And 75 out of 100 is 75%. If we had 5/8 to turn that into a percent. Blank out of 100. 5 times 100 is 500. Divided by 8 is going to be 62.5. So it's 62.5%. Or, last example, let's say we have 3 sevenths. 3 out of 7 is how much out of 100? 3 times 100 is 300. And divide by 7 to give us 42.857143%. Now, when you're doing something like that, of course, it has to tell you where to round it off. Let's say it tells you to round it to the nearest 100th percent. Well, that would be 10th hundredth, so that's going to round to 42.86%. Okay, so enough of the converting back and forth. I know that's long time review for most of you. Let's take a peek at doing some of our basic calculations. Again, I know this is review for you, but let's take just a quick look at some of them. We might have a problem like this. Blank is 70% of 90. When I'm dealing with these percent problems, I like to always start out with the percent. 70% is 70 out of 100. Now we have two other numbers here. We have the missing number here, the blank, and the 90. One of them has to match up with the 70. It has to represent the same thing as the 70. The other one has to represent the same thing as 100. So to figure that out, let's talk about what that 100 means down there. That 100 is actually a percent as well. It's 100%. And that means either the whole thing, the whole item, or a starting amount, an initial value. In this case, 70% is a piece of the whole thing. The 100 is the whole thing. So if we look at the wording of this question, there's two little tricks. One is blank is 70%, which tells us that the blank matches up with the 70%. The other thing we can look up here, of 90, we can read that as out of 90, which tells us that the 90 should go on bottom. Now we cross multiply and divide. 70 times 90 is 6,300. Divided by 100 is 63. So 63 is 70% of 90. We might have 40% of 30 is blank. This one is set up very different, but it is the exact same question. The calculation is pretty much identical. Again, I like to start with the percent. 40% is 40 out of 100. Now, because of the way this is set up and the way it's worded, the second part is a little trickier, figuring out what matches up with the 40 and what matches up with the 100. Again, I would look at it this way. 40% out of 30 implies that the 30 goes on bottom. Also, 40% is blank, implies that the blank goes with the 40. We cross multiply. 40 times 30 is 1,200. And divide by 100 gives us 12. So 40% of 30 is 12. We might have 27 is blank percent of 30. Now I said that I always start out with the percent, but here we don't have a percent. So I start out with blank over 100. Now we have the other two numbers, in this case the 27 and 30. And the setup should be getting easier. 27 is blank, so 27 goes with the missing percent of 30 or out of 30. So the 30 goes on bottom. Now just because the numbers are in a different place, it doesn't change anything. It's still cross multiply and divide. We're just cross multiplying in a different direction. 100 times 27 is 2700. Divided by 30 is 90. So 27 is 90% of 30. This next one, I'm going to word it kind of funny. It's going to be a little difficult. Blank percent of 40 is 52. So again, we're missing the percent. So it's blank out of 100. Now, a lot of people here say, well, the 52 is the bigger number. It has to go on bottom. But we have to be careful. Blank percent of 40 or out of 40 implies the 40 goes on bottom. Blank percent is 52. The 52 matches up with our missing percent. 100 times 52 is 5,200. Divided by 40 is 130. We get 130% of 40 is 52. If the ending result is bigger than the whole amount or the starting amount, the percent has to be larger than 100%. So we have this one. 32 is blank, or is 80% of blank. So we're back. We have the percent this time, so we're back to still starting there. 80% being 80 out of 100. Is 32 is 80%. So the 32 matches up with the 80 of blank or out of blank, implies the missing number goes on bottom. Again, the numbers are in different spots, but it's still going to be cross multiply and divide, just in a little bit different direction again. 100 times 32 is 3,200. Divided by 80 is going to give us 40. 32 is 80% of 40. %20 of blank is 16. So again, we have the percent. 20% is 20 over 100. Of blank or out of blank implies the missing numbers on bottom. 20% is 16, implies the 16 goes with the 20. We cross multiply and divide. 100 times 16 is 1,600. Divided by 20 is 80. 20% of 80 is 16. Now, I like the proportion method like this because to me, it saves a lot of mistakes. The calculation is always the same. Cross, multiply, and divide. You just have to figure out what numbers go with which and get them in there in the right spot. There is something that many of you may have been taught called the rate method. Using the rate method of percents, we said a rate was just the decimal version of a percent. Using the rate method, that's what we do is we convert it to a decimal. So 70% would become 0.7 or 0.70. And in a problem like this, you would do 90 times 0.7 gives us 63, which is our answer. And that seems a lot quicker and easier. And even this one, 40% would be 0.4 of 30. So it's 30 times 0.4 is 12. Again, that looks pretty quick and simple and easy. So why don't I like it that way? Well, if we go down to some of these. Here, you take the 80%, make it a decimal of 0.8. But it's not going to be 32 times 0.8. This one's going to be 32 divided by 0.8 to give us 40. Likewise down here, 20% is 0.2. It's 16 divided by 0.2 gives us 80. So if we use that rate method, we have to try to figure out, are we going to multiply by the rate or divide by the rate? And there's even a third kind of problem like this one where we're not given the percent. We have to take 27 divided by 30 to get 0.9, and then we have to move the decimal to make that rate into a percent of 90%. So there's 3 different types of calculation you have to remember and figure out which one to use. This is the way I was taught, by the way, and I'm pretty good at it, so that's the way I do it on my own a lot of times. And when you're doing some applications like interest and stuff like that, using the rate method is actually often quicker and easier, or commissions and things like that. But for the most part, I like using this proportion just because people make a lot less mistakes with it. In fact, when we get into word problems, it actually makes things easier. Let's say that United Corporation projects profits of $80,000 for the week. If projected profits are 15% of gross sales, what are the gross sales for the week? So, just like in the other problems, even in the word problems, I like to start out with a percent. I have 15%. So 15 out of 100. Now, I like to define what each of those means. Remember, the 15 means something, but the 100 also means something, the whole thing, right? So I have to look at here and ask, what is the piece and what is the whole thing? So I have profits and I have gross sales. So you have to ask, are gross sales a piece of the profits, or are profits a piece of the gross sales? And it doesn't take much time to realize the profits have to be a piece of the gross sales. So the gross sales are the whole thing. So that is the 100%, is the gross sales. Profits are 15%. So profits are the 15. Once we've done that, the rest of the problem sets itself up. The $80,000, is that profits or gross sales? Well, right there tells us it is profits. And now we simply have to cross multiply and divide. 100 times 80,000 divided by 15 is $533,333.33 of gross sales. Or we might look at Pat received, let's say Pat received a $4,000 raise. Pat's old salary was $28,000 per year. What is the percent of the raise? So we're looking for the percent this time. So something out of 100. We asked, what is the percent of the raise? So whatever this missing number is here, it's describing the amount of the raise. So on the other side here, $4,000 goes there. Now, you might be tempted just to plug the 28,000 in down here, but you have to ask yourself, is that 28,000 describing the whole amount or the beginning amount? And in this case, it is. The 28,000 is the starting amount, and then her raise is on top of that. So in this case, it is appropriate that the 28,000 goes down there with the 100. But you always should double check just to make sure. So now we'll find that missing percent by cross multiplying and dividing. 100 times 4,000 is 400,000 divided by 28,000, which gives us 14.28571 approximately percent, or 14.3% raise. Which, for those of you who don't know, that's a really good raise right now. Okay, so enough of the simple percent problems. Let's take the next step and look at Let's say that you are going to receive a discount. So you receive an 8% discount on merchandise list price is the full price for $230. How much do you pay? So here, there's a couple of ways we can approach it. Let's approach it the way that most people would dive in and try it first. Well, 8% is 8 out of 100 of the 230 is the full price. So we cross multiply and divide. 8 times 230 divided by 100 is $18.40. That is the amount of the discount. Now we still need to find out how much is paid. So we're going to take the $230 full price, subtract the $18.40 to get $211.60 is the amount paid. Now if we look at this, the 230, of course, was the full amount, or the list price in this case. $18.40 is the discount. And the $211.60 is the amount that is actually paid. But in a problem like this, there's always two numbers that describe each item. Here we had dollar amounts, but there will also be a percent. Now if we look at our percents, we have the 8%, which is the amount of the discount, but there's always another number that goes with our percents, and that is the 100. The starting amount, or the list price, was 100%. You can see 100 matches up with the 230 here. Same over here. Now with that, we can very quickly find the amount paid. Just like we subtracted the dollars, the percents get subtracted. 100 minus 8 is 92%. So rather than finding 8% here and having to subtract it out, we could have just found 92% of the 230. And if we cross multiply and divide there, it would give us $211.60 in just a single calculation. Now the problem we did here is probably just as easy to find the 8% and subtract it off as it is to try to find 92%. But there will be problems where you have to use that strategy. For example, let's say after a 20% discount, you pay $976. What was full price? Now here's one where, if I turned you loose, many of you would try to find 20% of 976. Then you would add it on to it. That would give you the wrong answer, because that 20% does not come from the 976. That 20% comes off of whatever that full price was, and that was a larger number. So 20% of that will not be the same as 20% of 976. So let's just kind of chart this out. We had the full price. We're subtracting a discount from it to get the amount that we paid. On the dollar side, we know that the amount paid is $976. On the percent side, we have 20% is the discount. We always know that 100% goes in here somewhere. That would be the full price. So the amount that we paid was 100 minus 20, or 80%. Now we are looking for what full price was, that number right there. So what we need here is we need one item where we know both the percent and the dollar amount, and that's this row down here. Then of course we need the item that has the amount we're looking for, which is that top row. What that's saying is we don't need this middle row here. I'm just going to ignore it for now. And our proportion is set up right in the table. We can cross multiply and divide right in here. 100 times 976 divided by 80 gives us $1,220. So the original price was $1,220. We could end up with something like this. We could say that rates will increase 12% next month. So find the new price of a procedure currently costing, come on, $3,500. So again, just like before, we could find 12%, 12 out of 100, of the $3,500, which is going to give us $420 is the increase in price. But again, we need to find the amount, the new price, which would be the $3,500 plus $420 is going to give us $3,920 is the new price. Well, just like before, we had an old price. To that, we added an increase to get a new price. And just like before, each of those items is described by two numbers. Once again, we had a dollar amount here. The other side is always going to be percents. So we had the 12%, which is the amount of the increase. There's still 100% is going to be the old price. The new price, now we're adding. 100 plus 12 is 112%. So rather than finding the 12% and adding it on, we could have just found 112% of 3,500. And when we cross multiplied and divided, that would have given us 3,920 in a single calculation. Now, once again, this problem could be easily done either way, finding the 12% and adding it on, or just finding 112%. But we can run into a problem like this, where after an 8% increase, let me rewrite that so it can actually be read. After an 8% increase, a machine costs $450. Find the old price. Here, you would be tempted to jump in and find 8% of 450 and subtract it out. That would not work because the 8% does not come off of the 450. You might be tempted to try to find 92% of the 450. Again, that wouldn't work either because that's assuming that the 450 is still the base amount. So we look here, we have the old price plus an increase gives us a new price. We have percents, and we're still dealing with dollars again over here. We know that the 450 is the new price. On the other side, we have 8% increase. Old price is 100%, so the new price is 108%. We want to know the old price here, so we're going to ignore this middle row and cross multiply and divide. 100 times 450 divided by 108 is $416.67. If you had tried to find 8% of 450, 8% of 450 is $36. You would have subtracted that and got $414. You'd have been almost $3 off. So when you're dealing with these percent increase and decrease problems, you have to be very careful, especially if the amount you're given is the amount after the increase or decrease. What percent you use is vital. You cannot use that as 100% because that's not the basis of the calculation. The basis of a percent calculation is always the starting amount. Okay, enough of that for the day. Let's give you some homework on page 36 and 37 in your book. 1 through 51 talks about percents. Let's just have you do the odd numbered problems. I will be sending out your test for Friday later today or early tomorrow. So your proctor should have that. On Friday, you'll have the whole class period to work on the test. My tests, I do allow up to 2 hours for the test. We will not take a second hour of class. Most people on the first test shouldn't take more than 2 hours anyway, or more than 1 hour anyway. But if you do need it, you can arrange for your facilitator at your location to use that extra hour to finish up the test. With that, does anybody have any questions? Okay, we will see you all on Wednesday.